Greetings, folks. Joseph Kerski here on collecting, analyzing, and mapping field data. Now, I would like to say that it's a huge honor for me to be addressing the GLOBE community. My organization, ESRI, Environmental Systems Research Institute, we've been working with GLOBE for years, about 20 years. We've worked on GLOBE at night together. We've done some other things together. I went up and saw Julie at her office in Boulder. We had a nice chat and a couple webinars not that long ago. And so it just seems to me that we should be doing more together because we're all about real world data and analyzing it. That is the focus of both of our organizations. So look forward to further conversations with you all. This presentation is really intended to be an ideas planter, folks. Yeah, you're not going to memorize all of these tools and data sets that I'm going to go through, especially in this short amount of time that we have together. But I know it's being recorded, and also the link for the entire presentation here is on my Twitter page. And so if you go to Joseph Kerski on Twitter, you can see that about 7 minutes ago, I've got this tweet that says, hey, my presentation for the GLOBE program is right here. So feel free to go through that. I've got, again, some immersive things that you can actually interact with in that presentation. So it's all there, hopefully useful for you all. Also, I am available for chats, talks, etc. So if you'd like to chat more about this, this is my contact information. This blog of mine about spatial reserves, it's all about having students really digging into the whys of where, and how do I know if the data is any good, and if it's a web map, can I trust it, and all that sort of thing, and where do I find mapping information, and so on. This video channel of mine has about 4,000 videos on it, all about space, place, environment, STEM, etc. So I'm rather passionate about this, as I know you all are, and that's another reason why I've been so looking forward to chatting with you all. So our objectives here today, in this short time that we have together, I want to explore the linkages between citizen science and mapping, okay, and collecting data in the GLOBE program, and even outside the GLOBE program, and then mapping and analyzing it. Why do we do that? How do we do that? Can I do that on the web? Yes. And then what topics can I teach, and how can I teach them using these tools and data sets that Joseph's going to ever so briefly go through. And then I'm going to also talk about a couple of tools to collect data out in the field and then bring them into a mapping environment or a geographic information systems, GIS environment. Now, to save bandwidth, I'm going to stop the video here. Hopefully that's okay. And then also, how can students communicate the results of their analysis? So basically what Julie was just talking about in terms of the science symposium, they could use one of these multimedia, for example, story maps to present their data and results of their research. So more about that in a moment. Hopefully that's a good introduction to what we're going to do here. Now, taking a sort of a stratosphere level view of this, is a high level view. Why maps? Well, maps have always been powerful means of communication, and now today we can use maps in 2D and 3D. We can incorporate real-time data, GLOBE data, and other data that is collected out in the field. Now, folks, I'm happy to say that I used to work at the U.S. Geological Survey. I worked there basically from the Cretaceous to the Holocene, a long period of time. I worked at the Census Bureau, I worked at NOAA, so most of my career is actually in data gathering organizations. And I've always loved paper maps, and there's still a use for paper maps in instruction. But I'm here to tell you that they definitely have limitations, as you know. You can't change the scale, you can't add data to it. And today's live digital web maps are different from all of that, and they're also different from maybe you took GIS in graduate school or as an undergraduate, and you say, yeah, Joseph, that was really a hard class, and it was kind of clunky and difficult to use. Well, yeah, it was. In the early days, it was quite challenging. But now, just like documents that you use and collaborate with others on, you've got Google Docs, you've got Dropbox, right? You've got other tools that you're using, and many of them are web-based, right? So you can collaborate. Same thing with GIS. It has evolved into this cloud-based platform that people can build on. So that has a lot of good implications to education. on a really practical level, for starters, you don't have to install anything. You're basically using a web browser, as I am right here. Okay, so why mapping for citizen science? Well, what we're interested in looking at, right, is not just gathering the data, globe or otherwise, with our students, right? We want to look at patterns, relationships, trends over space and time. And so what you're doing is actually anchored in a larger phenomenon that's going on. You contribute data to other mapping tools that are online on a daily basis. For example, if you pull up just a standard Google map of traffic, right? There's not a traffic meter every kilometer or something like that, right? It's basically generated on the fly from people moving at 10 kilometers an hour or 10 miles an hour through downtown Los Angeles, and therefore resulting in these red lines. So you may be contributing to this cloud-based citizen science platform anyway without you even realizing it. And also, I'm here to say that citizen science, including students, they're collecting data on a wide variety of topics, as you can see right here. And so, again, focusing on mapping, what we do with mapping is we don't want to do it just because it's there, right? As educators, you know that. You don't want to use a technology just because it exists. You want to use it if it enhances what you're doing in the classroom. And that's another reason why I think using these tools with a group of teachers right here are so compelling and so relevant to what you and I love about inquiry, problem-based learning, asking deep questions, and really keying in on some of the major issues of our time: water, energy, environment, and the others I have listed here. And being able to do that in outdoor and also in-class settings and fostering the critical thinking skills, all that good stuff. Okay, here's this sad kid. Why is this kid sad? Well, because without Geo Technologies, which, by the way, are one of the 3 hot topics or hot fields for the 21st century as identified by the US Department of Labor about 13 years ago now. They said, hey, nanotechnologies, biotechnologies, and geotechnologies, which is what we're focused on today, are the fast growth technologies for the 21st century. And without geotechnologies, which is what we're focused on here, there's no Uber, there's no geocaching, there's no web mapping, there's no directions to your favorite coffee shop, there's no efficient management of cities, smart cities, mass transit, and so on, assembly of your phone that you've got close by you right now. There is none of that. So one of the citizen science success stories is really this OpenStreetMap. So if I use OpenStreetMap, for example, in this platform we'll look at in a bit called ArcGIS Online, this is all citizen-created data. And so there are some good examples of mapped data that ordinary folks, including your students, have generated. Now, touching on what I mentioned earlier, Globe at Night, we worked with Globe on that. We have a project right now where we're having students looking at damage assessment for Puerto Rico for Hurricane Maria. And so this is all done in this platform called ArcGIS Online that I'll talk about in a moment. But having the pre and post Hurricane Maria imagery and having students tag buildings, because there's not enough people on the ground to do that. So students by the thousands are actually participating in that project and giving the results to the planners and the disaster mitigation folks on the ground there. It's rather grim, actually, because you can see the damage is actually all over the island, not just in a couple places. On a lighter note, here's sleeping dogs I took a picture of in Taiwan when I was teaching down there. The nice thing, folks, is that these tools and these data sets, they're definitely not sleep-inducing. They're actually quite exciting and quite lively, as hopefully I'll demonstrate here in a moment. So I want to focus today on, again, this is a sort of a bite-sized diet, gluten-free nugget, okay, of geospatial technology. You're not going to memorize all of these ways, but again, you can go back and investigate these when you have more time. So here's 5 ways I wanted to focus on today to gather and map data, okay, via crowdsourcing or having students going out there and collecting data. The first and easiest is mapping a spreadsheet, okay? And then we're going to talk about these other things in a moment. So let's talk about the method 1 here, creating a spreadsheet, and then you can collect data into it. So for example, How's everybody doing? Nobody asleep so far? Hope not.
Doing great. Just on mute everybody, so we will not have echo interference.
No
Doing
worries.
We're all excited.
Cool. All right, so I've gone to the Globe site, and I've gone to this awesome tool that Jennifer was telling me about, the Advanced Data Access Tool. And you enter that tool, and then you can grab spreadsheets of data, right, about air temperature, soil chemistry, and so on and so forth. So you get that data, it comes in as a spreadsheet. So if I go into ArcGIS Online, which is arcgis.com, and I add the data with this add button on the left side there, I can search for layers. I can also search for a layer on my own local computer, like this one right here. So if I go down and go to my spreadsheet right here, then I brought it in so I won't delay the webinar, but here is the spreadsheet that was right here in this tab. Now it's mapped, okay? And once I've got it on the map, I can say, oh, well, I want to map it based on air temperature at noon, okay? And I've got a bunch of choices. I can map by size, by color. I'm going to keep it at color. So I've got, let's pop up a legend here. The darker bluish are the higher temperatures, okay? And each one of these data points you can click on and get the information. So now you may say, well, gosh, that's pretty cool. How do I get the table of data? I can go to the layer and pop up this table, and then I can sort it and all that kind of stuff that you would think you could do in a regular geographic information system, and you can do it here. You can sort on temperature. So for example, we go right here and sort on descending, and then we go right here and say, oh, well, now I want to center on selection. Okay, well, the hottest temperature on this particular day that or actually several days that I've downloaded the data, is right here in the Central Valley of California. Okay, great. And so let me get some information about that. Nice. Okay, so the point is, why would I want to map it in this environment? Well, one of the reasons, folks, is that you have access to this thing called the Living Atlas of the World. This is a geographic information system. So you're not stuck with this base map that I showed earlier. You've got, in this Living Atlas, you've got biomes, you've got ecoregions, you've got ocean currents. Let me just show you a couple of those layers back on our map. I've got a couple things. I added the total annual precipitation. I've got the annual temperature, mean annual temperature. I've got the ecoregions on here. I can make these transparent if I want to, and so on. So the point is that I actually have access to a lot of different data sets that I can underlay or overlay on top of the data that I add from the Globe site. So, and that goes for any tabular spreadsheet. You can map it by city-country combination. You can have street addresses of historical buildings in your community or whatever. You can have lat-longs of tree species on your campus or the Globe data that you're collecting, etc. So you've got it accessed inside this web-based environment, and guess what? Now I can share this map with others. I can save it. I can do other things like analysis on it, like how many of these points that I've just brought in from the Globe data are on an elevation between 500 and 1,000 meters, or in an area that has a mean annual temperature of 20 but less than 30. It's that kind of thing. How many of these points are within 50 kilometers of the coastline? It's all that kind of stuff I can do once I've got it in my geographic information system environment. More about that in a bit. We better get back to our topic. So spreadsheet. One last thing about that. You saw me add that thing from my computer. It can be online too. So if I'm back on this map and I'm going to turn off some of my layers here. If I go to this one, this is current earthquakes, the last 30 days from the USGS, my former employer. So I can map by temperature, magnitude, depth, etc. So, and some of these data sets are global, right? So over by where Luke is, out in Northwest Europe or wherever, some of these data sets are global. Interesting. Now they're not all created equal, right? So I could take those symbols and map them by depth or by magnitude. So this layer right here, it's actually sitting online. It's not on my own local computer. So you can map things that are online as well as stuff that you've downloaded from the Globe site. Lastly, on that topic, when I say editable, what I mean by that is if you save that spreadsheet and you put it in this same mapping environment, you can make it editable. What does that mean? That means that other people can actually edit it. Think of Google Docs, right? Or Dropbox or some online spreadsheet that you've got. You've got other people that can add to it. And guess what? Those adds, those additions will be automatically reflected on your map because other people can add to it. Ooh, exciting times. Okay, so that's the note about spreadsheets. Okay, super. Let's go down to another way of adding data is with what we call a crowdsource story map. So I could, for example, set up, as I did here, a tree survey. And then I could have people upload photos and the locations and even the condition, the height, the species of that tree inside that crowdsource story map. What I mean by story maps is just a multimedia web map. Could have audio in it, could have video, could have narrative. More about that in a bit. But just, again, thinking about planting ideas with you all today, not necessarily, ooh, how do I make a story map? Well, there's tons of resources that I can share about that. Third thing I wanted to bring up is something called Survey 123. Now, many of you, probably all of you, have used a survey in the past. You've used SurveyMonkey, you've used Google Forms, whatever. You've used a survey, you've created it, and a survey could be something like this. Hey, tree mapping, deciduous or evergreen, okay, condition, good, fair, poor, height, whatever, meters, feet, whatever you want to use for your units, and then species. And then, okay, where is it? Now, if you're out in the field, if you have your location-based services on your smartphone, it'll say, oh, okay, you're right here. In this case, Boulder. I'm just down the road from Julie, actually. And then, do you want to submit a photograph? Great. But then, again, folks, once you've done that, then you can map it, which I've done here with that exact same form. Now I've got a live web map of that data, and I can symbolize it. Again, I can put it on top of existing vegetation cover of a community, etc. So, very nice. We are on a roll. We are on a roll. Okay, so now let's just think about that. Survey 123, form-based and map-enabled. All right, another one that's very much related to Survey 123 is something called Collector. Gives you a little bit more functionality, and I have some videos about how to use both of those tools as well. One thing that I would like to note, with both of those, you can actually collect offline. So let's say you're out in the middle of nowhere, right? You're out in the middle of heavy tree cover or in a canyon somewhere with your students, and you don't have Wi-Fi. You know, you're not connected to anything. Well, you can collect the data using each one of these tools, and then later on, you can sync the data that you collect up with the live web maps. Very nice. Okay, here is a result of a project. Actually, Luke who's one of our participants. He actually participated in this particular one. So we had a group of educators out in a, as you can see here, in this case, it was an urban setting, and we had them collect tree species, light poles, condition of sidewalk, etc. So in this case, we had a couple of things that the people were collecting, and here's the photo that this person actually uploaded to the same location. So I've got an interactive map that is, again, could be editable, so I could keep adding to it until which time I'm done, and then I could turn off the editing and nobody could add to it at that point. And you can see that I can symbolize it in whatever way I want. And then I can do things like, what's the distribution of the tree height on north-facing versus south-facing slopes? Or how does the water quality vary across this reach of a river, right? The dissolved oxygen, the conductivity, the pH, etc. Right? We're always interested in looking at patterns and relationships and trends. We don't want to just stick points on a map and call it good. All right, so another tool, iNaturalist. I, like maybe some of you, have been participating in BioBlitz projects over the years where students go out and they collect every single tree or plant species or animal species that they can in a certain amount of time. It's usually 24 hours. But there is a tool called iNaturalist that's frequently used in such settings. And in these two links, I've got, well, okay, iNaturalist spits out a spreadsheet. And guess what? You can map that, right? Just like we were the earlier stuff. So here's output from iNaturalist. The nice thing about that is that it has a huge database of, okay, it's a spruce. And then it says, oh, what kind of spruce is it? Here's a photo of 20 different kinds of spruce trees. Identify which one it is. So iNaturalist is a very nice tool that way. Again, just running on a phone. All right, last closing comments here. I touched on this. Don't just map it. Analyze it. Analyze the results. Now, inside this same platform that we've been talking about, this ArcGIS Online platform, is the ability to do some analysis. You can generate statistically significant hotspots. You can intersect things. So in this particular lesson, I have students looking at Julie, you'll be familiar with this. This is Boulder, Colorado. So what areas are close to landslide potential and they are within 200 meters of a stream? So they intersect both of those things, and this is the areas that are resulting, these black outlined areas, and those are the areas that the students will focus on for their research. Okay, so analysis capabilities. Now here's an array of story maps. If you're done with your investigation, you can use the same platform that I've been identifying all afternoon here to communicate the results of your research. So, for example, let's look at, oh, well, I want to look at any one of these. Let's say we look at, how about this one on the Osceola, Iowa trail. So here's a story map that I built based on a bunch of photos that I took of a proposed trail in a community out in Iowa, and I built a little story map around it. So you can see it's a very simple one. It's got a couple of photographs in it. It's got some captions, and it has the route of the proposed trail, which actually follows the power line and pipeline right-of-ways. So pros and cons that the community is debating. So that's just a story map of that proposed trail. And so I can use this just like I would a Prezi or a PowerPoint or any other types of communication. I can build that, and guess what? This live web map and this stuff that you see right here, it's all based on the same platform. So I could bring in the biomes, the median age of the community, the median income, the variety of other. Wish I could get excited about this. Okay, so let's move on. I would like to close this part with a couple resources. Here's a geeky picture of me out in the middle of nowhere. Okay. First of all, ArcGIS Online. We've been focusing on it all day. Is that the only mapping platform available to you as an educator? No, it's not. But it has certain advantages. A, it's free. B, it's a real GIS. It's not just points on a base map. Okay, in other words, it has analytical capabilities. It has ways you can add to it. How do you get ArcGIS Online? Well, first of all, ArcGIS there's lots you can do without logging in. Okay, so you can look at biomes and ecoregions and energy and watersheds and all that kind of stuff, population, distribution, and change without even logging in. If you want to log in, though, then you'll need an account, just like you want to log into Google Docs. Now, the good news is that if you're a school, you can get a free subscription. Public school, private school, homeschool, doesn't matter. So you can go and get a free subscription so that your students and you can save your maps, share your maps, make story maps, use Survey 123, etc. There's a whole boatload of resources in terms of lessons and data sets and so on. So I've got some links here for some of the things that I touched on, Survey 123, story maps, and I have a mobile field data collection set of activities that you can dig into. And once again, this whole presentation demonstrated a couple things. A, notice that these web maps you can embed, right, like I've done here, into different kinds of multimedia. In this case, it's a Microsoft Sway presentation, but it could have easily been a story map that I was presenting. It could be a Prezi. It could be your own web page, and you can incorporate and embed these live web maps into it. Once again, the presentation is out on my Twitter page right here at the top. It's 31 minutes old now, but I wanted to kind of close it off there because I'm conscious of the time, and I want to open it up for questions, comments, complaints, issues, all kinds of other things. Again, don't feel like you've got to memorize all this stuff, folks. This is like science. This is like biology. Learning and using geographic information systems, while it is much improved from the old desktop-only days, having it online, there's still some moving parts that you kind of need to wrap your head around. So again, don't give yourself such pressure that I've got to learn GIS in 30 minutes. Well, it's like learning chemistry. It's a lifetime endeavor. Questions, comments, complaints?
You touched upon this, and this is Larissa again. Can you very briefly, again, summarize the mobile use for that? Because many of our students, they they only have Chromebooks, or they have like a simple smartphone, nothing like fancy.
Yeah, absolutely. I'd say about 65% of what you can do inside this ArcGIS Online platform, you can do on an iPad. Once you get into the, I've got to have a file management system, then those are the things that are excluded from the iPad. But there's over half this stuff you can do on an iPad. With a Chromebook, it's up to about 90%. You can do 90% on this. I've got a tablet right here that is that I'm running ArcGIS Online on just fine. And I'm presenting this with a regular laptop, but that's the good news, is that you can actually run this with extremely limited resources. And again, that's such the advantage. The old days, which isn't that long ago, you had to be in a lab in a school, and you had to install software and get all this to work, and you had to have a high-end graphics card in your computer, and all the rest of it. Forget about it. You don't have to do any of that anymore. Not to say that there's not desktop GIS, because there still is if you truly wanted to dig into more functionality. But there's plenty of functionality in these online tools.
What about data submission via your cell phone?
Right. Yep. So any smartphone would work with all the stuff that I identified. Or sometimes I still use regular old GPS receivers, the standard, Garmin type of low-end receivers. And, then I also use a clipboard and just have the students. Sometimes I think it's worth having them actually construct a little table of data. It's actually good, so that when they pull up, for example, these things that I showed with the data inside here, the data table, for example, this, how does that get constructed? I think there's value in having students actually construct a table of data. So I don't do everything automated. I have a couple of activities where okay, you're going to construct a table. You got to have the latitude. You got to have the longitude. Why is my point end up over in Kazakhstan? Well, because you didn't put a negative sign in front of your longitude, so it thinks it's Eastern Hemisphere. All those kinds of things actually are good teachable moments.
Thank you very much. Excellent presentation. Thanks.
Glad you're on here, Larissa. Awesome.
Thank you.
Somebody had a question about the URL for the disaster site.
Yep. For Puerto Rico.
That was me, Joseph, asking about it, because I heard about this system, but I'm forgotten the address where I have to find it.
No worries. So we have a zone. It's pretty geeky, folks, but it's the social, networking for the people using these tools. It's called GeoNet, and inside GeoNet, there is a education zone, as you would expect. So people that are interested in using geographic information systems in the classroom. And by the way, that is the whole focus of the team that I'm on. I also teach at the University of Denver, but my ESRI role is helping educators use these tools and think about why should we even use these tools. So, for example, if I go to the education zone inside GeoNet, it's in there. So if you scroll down, you'll see the Puerto Rico mapping. And I had my University of Denver students doing it. There's some secondary students actually participating, and that's just one of many, crowdsourcing kinds of projects that get the students thinking about, ooh, I'm not just going to collect data, but I'm actually going to help someone as I'm contributing to this sort of global community.
And there was another question, can images be linked by 360 panoramic? Cassie, do you want to say anything about that? I'm not sure if you want to comment or describe that.
I know Cassie, she's awesome.
Hi, Joseph. I'm just wondering if, the linkable map, back to your Iowa example, if you clicked on an image and you have it, like I have some stuff in Google Street View that's 360, can those images be showed up in a story map?
Yeah, the key, and I've got a document on that basically I have to update every few months because these, as you know, these photo sharing tools change, but it's how to use Google images, how to use Dropbox images, how to use Flickr, etc. The key is if you can pull it up in a separate tab on a browser. So if it's wrapped in a frame, like oftentimes Facebook images are, and you have to log in and stuff like that, then those won't work. But if you can actually pull it up in a separate tab, then that's good. So if your 360 immersives, you can actually pull up in a web browser, great, then they'll work. And as long as there's no login that someone has to get to, because most of this information, you can link to, as Cassie is indicating, to your point. So you want to click on a point and see what does it look like right there? What is the water quality like, or the tree species, or the condition of the graffiti, or whatever it is that you're mapping and analyzing.